Sometimes we need to rely on third-party dependencies and external APIs in order to achieve the functionality that our app offers. And as we all know, dependencies equal points of failure. You don't own what you don't control, and therefore it is super important to keep an eye on that in production. Hey, I'm Lazar from Sentry, and in this video I want to show you how you can use Sentry to monitor external APIs and see if they're causing any slowdowns. Once we do, we're going to create alerts and dashboard widgets so we can continue keeping an eye on them in production. For this demo, I'm going to be using a React Native application with a fast API backend, but bear in mind that you can actually do this with Sentry in virtually any framework or technology. So without further ado, let's dive in. So here's the React Native application. It is basically a stock analysis application. We have stocks like Tech Corp Industries, Cloud9 Systems, Artificial Intelligence Co. Of course, these are non-existent, but the issue that we're seeing is that sometimes we get fast results, sometimes we get relatively fast results, but sometimes we get some seriously slow results, like this one, for example. And since we built this app, we know that we don't own the data. We use an external API to fetch all of the stock data and the analysis data. So we kind of suspect that it might be the external API, but let's actually confirm. Let's go over in Sentry, go to the Insights page, click on the mobile and select the Expo project. This is the mobile overview page, and we basically see the P50 durations for all of the spans, P95. We can even change this to P75 if we wanted to. But if we zoom in on this block right here, we can see that the P75, P95, they're actually in the 8 seconds, 6.98. We can see that something is going on. We can check out the mobile vitals or, for example, the network requests, and we might be able to see that we are sending HTTP requests to localhost 3001. And there are two screens, the stock list and stock detail, and the stock detail definitely takes a lot more than the stock lists. So we can see that there is something going on with the application, but there is a better way or better screen in Sentry that'll give us much more detail. So let's go to the Explore page, click on the Traces, select our project, and click on the Trace Samples tab. I'm going to collapse this one to make more room for the table. Alright, so on this page we can see all of the traces, how many spans they had, the timeline, and the root duration. We can see some of them take 5 seconds, some of them 3.42, and some of them 145 milliseconds. Alright, so let's go back and investigate what is the difference between the 5-second traces, the 145 millisecond traces, and also the higher or slower traces, like for example this one. It takes nearly 10 seconds. So I'm going to collapse this one to look at the trace details here. I'm going to collapse the 3-second one and also the 145 millisecond one. And I'm also going to go up and collapse even this part right here because we need as much room as possible. Okay, so we can see that for the 10 seconds trace, we are sending an API request to localhost 3001, that's basically our backend, and we're requesting the tech stock details. And at one time it took 5.02 seconds, the other time took 5.04. If we look at the other trace, we can see that we're requesting stock details for the VR stock, and at the bottom we can see that for the 145 millisecond trace, we're requesting stock details for the AI stock. So this kind of tells us that depending on the type of stock or depending on the stock itself, we're getting some different results. In order to confirm that, we need to isolate all of the spans that send the requests and group them by the stock type. So let's just copy the span details like this, go up and search for span.description. Paste that, and instead of AI, we're going to use a star, an asterisk, as a wildcard. All right, now we're going to click on the span samples, and here are all of the spans that request stock details. And the results are pretty much as expected. We have some 5-second requests, we have some 800 millisecond requests, 137. But in order to group them, we're going to expand the sidebar here and go to the aggregates. We're going to select P95 for the visualization and group them by URL. There we go. Now let's just drag to zoom into this part right here, and to make things more obvious, instead of a bar, we're going to use a line. Okay, now we can see that we created groups based on all of the stock details, and they're all color-coded. And based on a table, we can see that the tech and data stocks, their P95 is 5 seconds, whereas the other three are less than 2. If we change this to P75, we're going to see a better difference, something closer to what we inspected. Tech and data are 5 seconds, cloud is 1.5, and AI is 134. Alright, so this confirms that based on the stock that we're requesting, we either get a fast response like the AI one, or very slow response like the tech one. And because we're getting this data from an external API, we need to confirm that the slowdown actually happens because of the external API. In order to do that, we need to find the spans on the backend that send the request to the external API and overlay that chart on top of this one. So to do that, we're just going to go and click on Compare Queries. Alright, from this screen, aside from the React Native project, we're also going to select the Fast API backend project. In the top chart, we're going to add that the project is actually the Expo one. But in the bottom one, we're going to set that the project is the Fast API. And aside from this, we're also going to add the span description, external API.com on port 3002/stock analysis, and then asterisk for the wildcard. Okay, this gives us some data, but we also need to match the visualization. So if we have P75 at the top, we're just going to select P75 at the bottom and also group them by URL, just like the top chart. Okay, so once we do that, we can actually see that the top chart and the bottom chart are basically the same, as if we're looking at the same data. But we're not. The top chart represents spans that are captured from the Expo application, which is JavaScript. And the bottom one is spans that are captured by the Fast API application, which is Python. But because we're using the Fast API as more of a BFF framework, backend for frontend, but the actual data comes from the external API, that's why these two charts are virtually the same. So with this investigation, we can confirm that indeed the external API is causing the slowdown. It's not our backend. And what we can do from this point on, well, caching. If these requests are predictable and the results are not changing too often, then we can always cache the results. But before we actually jump into implementing caching, it's a good idea to spend some time investigating why the external API is slow. Maybe it's just a simple misconfiguration, or maybe now is the time to upgrade to a better plan if the API offers it. We can even reach out to the developers that work on this API and tell them about the slowdown. But whatever it is and however we fix it, we're still gonna need to create some alerts and dashboard widgets in case this issue regresses. So let's just do that. We're gonna go back to the Trace Explorer screen, and to create an alert, instead of comparing the queries, we're going to save this as an alert. The alert is going to be the P75 value of any span in the Expo external API project whose description matches this. And we also want to set thresholds. For example, it's critical if the API takes more than 3 seconds to reply back. We want to get a warning if the API takes more than 1.5 seconds, and anything below 1.5 seconds should be automatically resolved. Alright, we of course want to set an action, so when this alert reaches the critical status, we want to email myself, and if we reach a warning, I'm going to send a Slack message and tag myself. Now we just need to give this alert a name, something like Stock Analysis API, and we'll hit Save Rule. Now this alert rule is live, so if our backend doesn't respond within 3 seconds, we are getting an email. But if it takes more than 1.5 seconds, we're gonna get a Slack message. And this is how you can create an alert. As I mentioned, we can also create a dashboard widget to help us keep an eye on the P75 or P95 value in production. So let's just do that. We're gonna go back to the Trace Explorer. No need to change anything, we just need to click on Save As, and instead of Alert, we're going to save a dashboard widget. It'll ask us if we want to add it to any dashboards or create a new one. I'm going to add it to the Backend Overview dashboard. And now we get to configure the widget itself. As you can see, the type is set to line. I'm going to keep it as line. P75 is inherited, the filter is also inherited, and even the grouping is inherited from the filter that we defined on the Trace Explorer page. We can play with the sorts, like what is the limit, or whether we want high to low or low to high. I'm not going to change this, I'm just going to give this a name, and I'm going to call it Stock Analysis API. And I'm just going to click Add Widget. Alright, so this is my backend overview dashboard. If I scroll all the way to the bottom, we can see the Stock Analysis API. We can make this larger if we wanted to by clicking on the Edit Dashboard and just dragging its size, hit Save, and there we go. This is much more comfortable. And we can also drag to zoom into specific areas. And there we go. Aside from all of the other widgets, I also have a widget that will give me an overview of how long it takes for the backend to return the stock analysis data. And that's about it. I hope this video helps you. Thanks for watching, and I'll see you in the next one.